Hi everyone, I'm going to go over an introduction to object-oriented programming and why we care about object-oriented programming and what exactly an object is. So first, let's talk about object-oriented programming and defining it so that we have a definition to work with. Object-oriented programming is a programming methodology that views programs as consisting of a series of objects. These objects are meant to interact with each other through actions that we call methods. Now, if you've used C++ before, then you should know that we usually call pieces of reusable code little blocks that you might need to call several times, a subroutine or a function. Now, in Java, we mostly call these methods, and this is partly because of the fact that Java follows an object-oriented programming approach to its language structure. So methods are the way that our objects are going to interact with each other and with the rest of the program. Objects of the same kind or of the same type are a class. Another way to look at this is if we have an integer, right? If we have an integer variable type, then something that is of a similar integer value type, they're the same type. Objects, so we can have an object of class car and another object that is different that is of class car, and they're of the same type, but they have different values. Just like if we had an integer x and an integer y, they're of the same type, they're both integers, but their values are probably different. So what exactly is an object anyway, though? So we've talked a little bit about what object-oriented programming is. It's a methodology that we're going to use to make a little bit more reusable code, but we have to get around this idea of an object. So objects are representations of a real-world physical object as pieces of code. Our goal is to capture the idea of the object, including physical attributes, data members, and actions that that object might need to use in the real world. Now, keep in mind that a particular object or a particular thing in the real world, let's say for example a person, might have many things that it needs to be able to do in the real world. When we're defining objects in our code, we're not trying to capture all of those things, we're only trying to capture the things relevant to our program. So let's take a look at, again, what this means. So what is the physical attributes? Physical attributes are things that you look at the object. So let's take a look at a marker, right? If we look at a marker, we can see the color of the marker, the shape, the size, the brand, right? These are things that we can see usually on the marker itself. If we take a look at a different type of object, maybe like a car, we can see the color of the car, number of wheels it has, number of doors. These are the kind of physical attributes that we want to start with. These are the easy things that we can go, yep, we're going to need that information because that's relevant to our program for some reason, and we need that represented in the code in some way. So we need to represent how many doors it has. We need to represent what color it is. But the next thing we want to talk about is data. Now, the physical attributes and the data in the code are both going to be represented by the same thing. That's instance variables. Now, instance variables are just variables that belong to a particular object, and we'll go over what that looks like in another lecture, but just remember that these are going to be represented by the same thing, instance variables. They're all technically data. Now, when I say data, though, here, what I'm talking about is the things that you can't see. The mileage on the car, the ink level of the marker, and the year that a car was made. These aren't things that you physically see when you first look at a car. It's data that we inscribe onto it in some fashion, or it's something we measure, like how much fuel is left in the tank, right? That's something we measure with a gauge. Next is the actions. So what do you need your object to do? Well, for a marker, you're going to want it to write. For a car, you might want it to drive or stop. So let's take a look at actually breaking down a real-world object, such as a car, and turning it into an object in code. So the first thing we do when we look at this car, we're going to take a look and break it down into its different components that we might need in a program. Now realize I'm not giving you any context for what kind of program you're writing, and that's not really important at the current moment, but when you're writing a new program, you're going to want to evaluate the context of your program and what you actually need out of the object. So we're going to take a look at this car, and the first thing we're going to look at is its color. So if you look at this car, it is red, right? That is its primary color. That's the color we would represent it by in the real world. When you go to register your vehicle, you would say red. We also look at the number of doors. In this case, we have 2 doors, and then we'd look at the number of wheels. In this case, 4. Now, some cars, some vehicles may have less wheels or more, and other vehicles will have different amounts of doors. So this is all representation of this specific car, this specific object. Next, we're going to look at the data that we can't really see. So we're going to write down its year, its make, model, the number of miles it has, and its max speed. These are all relevant to whether or not we're going to be maybe buying this car, or it's data about how much the car would eventually be worth, right? So if you're going to sell a car, for example, all the things that I mentioned before are important. You want to know how many doors it has because it's the type of car that it is. You want to know what color it is. You want to know, make sure it has all 4 of its wheels. But then you also want to make sure that you know its year, when it was made, what kind of car it is, what make, what model, right? How many miles it has on it is important to you as well. And also, perhaps its max speed is important to you. Next, we're going to talk about its actions. So for a car, we want it to drive or move. We want it to brake or stop, and we want it to open and close. Now, these are all actions that we're going to want it to do. So we want it to be able to move on the road. That's important. We also want to make sure that it can stop moving at some point. And we want it to open so we can get people into the car, and then close so that the doors close when they start driving. But why objects? Why are we describing objects in this way? Why do we want to represent objects in this way in our code? Well, it really comes down to having an easier conceptual structure. We are very good at taking things that we see in the real world and translating those things into pieces of data, generally speaking. This is something that human beings are good at, and it's something that's a widespread skill. So representing that in our code makes sense. The other thing is following a DRY philosophy. DRY stands for don't repeat yourself. All right, it creates reusable code, so we can take particular actions or methods for our objects and put them in different objects or put them in different types of classes and be able to reuse that code in a lot of ways. That's really useful, but we can also reuse different types of classes in different programs, which is also really useful. Note, however, that objects are not the abstraction of an idea. A car is a class. A type of car, like a Ford Taurus, or perhaps a sedan, is a child class of that overall car archetype, right? But my specific Ford Taurus is an object. It's an instantiation. It is a value of that class, right? Just the same way that we might have an abstract number, right? And from that, we might have integers and doubles. Those are both types of numbers. And then we have an actual value like the number 5 or 5.0, which would indicate that those are specific values to a particular type of number. And that's really important. It's that objects are not the abstraction. They themselves are the actual value to a particular type. Classes themselves are the abstraction, and objects are a specific instance, or sometimes known as an instantiation of that particular class. So the object's purpose, and in general a class's purpose, is these 4 things: encapsulation, inheritance, abstraction, and polymorphism. Now, don't worry too much about these right now. I'm just going to give you a high-level overview, and we're going to be talking more about them later. But the first thing that you should really know about objects is encapsulation. So if we have a pill capsule, for example, from what you'd get from your doctor, maybe it's a vitamin, and it contains powder inside, right? The powder being the medicine. The capsule itself just contains and capsules those things together. Well, that's the same purpose as a class. So an object of a type of class is going to contain information inside of it that is important to that particular object. So the first thing it's going to contain is data. So this is that physical attributes and that data that we talked about. The second thing that it's going to do is contain actions or methods that that object needs to be able to do. Now it contains all of these, and we're able to move that object around with all of that stuff together. So just the same way you would move a pill around to different places, you can move that object around to different places without having to move the individual components on their own. Next is inheritance. So if we start with a particular object type, so let's say we wanted to talk about sedans, right? So we have a sedan, and this is going to work very similarly to how it would work in real life, right? You have a parent, and from that parent, you're going to spawn children. So a parent in this case might be a sedan, and we want to spawn different types of sedans. We want different types of children. So maybe we have a Ford Taurus, maybe we have another type of sedan in there, maybe we have a Chrysler. These are just different types of children that inherit properties and actions. So they'll inherit instance variables, they'll inherit properties, they'll inherit methods from their parent class or their parent object. And this allows us to reuse a lot of that data, that information we were talking about before, which allows us to do the next really cool thing, which is abstraction. Abstraction lets us take something like a vehicle, and we can define a lot of things about vehicles in general. They should be able to move, they should be able to stop, they might have a number of wheels, right? So these are things that we want to be able to keep track of in general for all vehicles. Next, we might break that down into things like a bicycle and a car. Now there's other types of vehicles out there, but these are the two that we're going to be talking about. So a bicycle and a car is going to inherit things from a vehicle, and it allows us to abstract data out into that vehicle, and we don't have to put it specifically in the bicycle or the car. Instead, we can just say number of wheels, for instance, can be in the vehicle class. We then inherit that as a data property and can still interact with it as a bicycle and a car, but we don't have to define that in the code specifically ourselves. Next, we might want to say different types of cars, such as a sedan, a coupe, or a truck, right, which inherit, again, properties from car, which also inherits from vehicle, and that chain of inheritance is really important, that we can inherit things from vehicle through car if we're, for example, a sedan. Now, each of these are going to have perhaps different data values. For example, a car is going to inherit perhaps number of wheels as a data value from vehicle, but it's also going to have one that bicycle doesn't have, that vehicle doesn't have, which is number of doors. So number of doors might be something car has, but the sedan, the coupe, and the truck are all going to overwrite that value with something of their own, and that is actually something known as polymorphism. So in this picture that I have on the screen, we have different animals on the screen all saying their associated verbiage. So we have a duck, a dog, and a cat, and the duck says quack, dog says woof, cat says meow, and then we have a person telling them all to speak. So in the same way that we might overwrite specific values for the number of doors in that abstraction that I showed you earlier, we might also have them behave differently for different methods that they might take. This is called polymorphism. For example, in this diagram here, we want all of the animals to speak, and we have an abstraction of animal, and we have speak in there, but it's specifically defined differently for duck, dog, and cat than it would be defined for a generic animal. Now, this is really important because, again, it allows us to reuse a lot of our code and a lot of our infrastructure for that code. All right, so next up, we are going to talk about classes and defining them. And remember, what I gave you here about abstraction, inheritance, polymorphism, and encapsulation, this is all just an overview. We'll go over more of that later in this semester.